Let's look at OpenStax College Physics, Chapter 13, Problem 29. An airplane passenger has 100 cubic centimeters of air in his stomach just before the plane takes off from a sea-level airport. What volume will the air have at cruising altitude if cabin pressure drops to 7.5 times 10 to the 4th newtons per meter squared? So let's write down the things that we know. We know that the initial volume of the air bubble that the person has in his stomach is 100 cubic centimeters, and we have to convert this into cubic meters, so that is 100 times 10 to the negative 6th cubic meters. The initial pressure is at sea level, so that is 1.013 times 10 to the 5th pascals. And we know that the final pressure at cruising altitude is 7.5 times 10 to the 4th newtons per meter squared. Now, we know that the person's body temperature doesn't change from sea level to cruising altitude, so the temperature is going to be the same at both locations. So I'm going to say T initial is T final. We're looking for the final volume of this air bubble. So here I have the stomach, here's the air bubble, and then we'll want to know how much that volume changes. So we know that at sea level, initially, we have P initial, V initial is nRT initial, and then at cruising altitude, we have P final, V final equals nRT final. From this setting nr equal to nr, we end up with P initial, V initial over T initial equals P final, V final divided by T final. But we know that the temperatures are the same, so we can cancel those out, and then we're left with P initial, V initial equals P final, V final, also known as Boyle's law. We're looking for V final, and that's P initial, V initial divided by P final. So now we put in the numbers. P initial is 1.013 times 10 to the 5th. V initial is 100 times 10 to the negative 6 cubic meters divided by P final, which is 7.5 times 10 to the 4th newtons per meter squared, which are pascals. And when we plug the numbers into our calculator, we end up with 1.35 times 10 to the negative 4th cubic meters, and we can convert that back into centimeters cubed and end up with 135 cubic centimeters. So the final volume of that air bubble in the passenger's stomach has grown.